We are in section 2.5, Marginal Analysis and Approximations Using Increments. Marginal cost. If C of X is the total cost of producing X units of a commodity, then the marginal cost of producing X naught units is the derivative C prime of X naught. For X naught sufficiently large, the marginal cost C prime of X naught can be used to estimate the additional cost of the additional unit, so C of X naught plus 1 minus C of X naught, is incurred while the level of production increases from X naught plus 1 to X naught. Similarly, the same holds true for marginal revenue and marginal profit. Example, a manufacturer estimates that when X units of a particular commodity are produced, the total cost will be C of X equals 1/8 X squared plus 3X plus $98, and furthermore, that all X units will be sold when the price is P of X equals 1/3 times 75 minus X dollars per unit. Find the marginal cost and marginal revenue. So marginal, again, is that keyword that means take a derivative. So our marginal cost would be C prime of X, and our cost function is listed up above. And so in order to do this, we're going to have 1/8 times 2X plus 3, which is going to simplify to 1/4 X plus 3. And this is our marginal cost function. Go ahead and box that. And then our marginal revenue would be R prime of X. And so the derivative of R, we have a little bit of a problem because I don't see an R function given to us. But again, remember, R of X would be equal to X times P of X. So those number of units times that price. And so we have X times P. P is 1/3 times 75 minus X. And so I'm going to go ahead and distribute through the 1/3 and also the X. And so I'm going to end up with 75 divided by 3 is 25 X minus 1/3 X squared. And so now taking the derivative of this revenue function, we get 25 minus 2/3 X. And so this will be our marginal revenue function. Part B says use marginal cost to estimate the cost of producing the 37th unit. And it says what is the actual cost of producing this 37th unit? So a change in the cost of producing from 36th to 37th unit, and the cost by estimating is by finding C prime of 36. So the cost of producing the 36th to 37th unit can be estimated by finding C prime of 36. So again, this is marginal meant additionally 1. So notice that we're substituting in that 36th value in. And so our C prime of 36 would be equal to 1/4 times 36 plus 3, which works out to being $12. So this is the estimate in producing the 37th unit that would cost an additional $12. The actual cost we can find by taking the cost of 37 minus the cost of 36 and subtracting those. And so we have our original C function given to us up above. And so substituting in 37 into our cost function up above, we get 380.125. And substituting in 36 into our cost function up above that was given to us, we get 368. Subtracting this, we get, and we'll round 2 decimal places, $12.13. So we have our actual, and then we also have our estimated. Part C says use marginal revenue to estimate the revenue derived from the sale of the 37th unit. and it says what is the actual revenue derived from the sale of the 37th unit, and it also wants the estimated. And so to find this estimate, we're going to have R prime at 36 and substitute this into our equation. We have 25 minus 2/3 times 36, which works out to being 1. So this would be $1 revenue for that 37th unit. To find our actual, we can find R of 37 minus R of 36. And so R of 37, while substituting that into the equation, we have 468.67 minus R of 36, which is 468. And this works out to being 0.67. And so this would be our actual, and our dollar was our estimate. The example right below says Quentin is a business manager for a company that manufactures digital cameras. He determines that when X hundred cameras are produced, the total profit will be P $1,000, where P of X equals negative 0.0035 X cubed plus 0.07 X squared plus 25X minus 200. Quentin plans to use the marginal profit to make decisions regarding future production. So part A says what is the marginal profit? So we have our profit function that we need to take the derivative of, and we were given our profit function up above. And so taking the derivative of this, we have negative 0.0035 times 3, which is going to be negative 1.0105 X squared. And then we have 0.07 times 2, which is going to be plus 0.14x. And then 25x, the derivative of that's just 25. Derivative of negative 200 would be 0. So this is our marginal profit function. Part B says the current level of production is X equals 10. So 1,000 cameras. Based on the marginal profit at this level of production, should Quentin recommend increasing or decreasing productions to increase profit? So his marginal profit, so for one additional 1,000 units for these cameras, I'm going to go ahead and substitute in 10. Substituting in 10 up above to our derivative for X. This is going to work out to being 2535. So a 1 unit increase will increase profit by about $25.35 thousand. And so again, our units are in 100 of cameras. So we'll say a 1 unit, which is going to be X 100 cameras, so 100 cameras, will increase because this is positive. So we'll increase profit by about, and again this is our estimate, so about $25.35 thousand, because those are our units up above. And so since this is a positive increase with profit, we're going to say that he should increase. So we'll say, so increase production. Part C says the current level of production is X equals 80, or 80,000 cameras. Based on the marginal profit at this level of production, should Quentin recommend increasing or decreasing production to increase profit? So P prime of, and we have 80. So substituting in 80 into our marginal profit function, which is listed up above, we get negative 31. And so a 1 unit or 100 cameras increase, So if we increase this by 1 unit, we'll decrease, since our answer is negative, profit by about $31,000. So at this point, it's not smart to increase production. We'd actually would say, so decrease production.